Alright, so this is lesson 3.2, and it is about finding missing angles. This is a flipped classroom, so you should be watching this at home, writing your notes, what you learned today on the video, and then coming to school and practicing with help at the school. So, let's get started. 3.2. First, we're going to remind ourselves about the easiest way to find angles. And the easiest way to find angles is to use a little trick that we learned, that when we have two angles, like we have here, we can always find the third by using some simple subtraction. Because all angles in a triangle must add up to 180 degrees. If this is true, then anytime we have two angles, like we do in this question here, we can go 180, and we can subtract the other two angles, and we would end up getting the third angle. So 180 minus 33 minus 34 would give you 113, so that would be the missing angle. We can do that again, even for our right angle triangles. We know we have a 90 degree here, because that's what that little box means. The other one is 29, so if we go 180 minus 90 minus 29, we should be able to get our missing angle, which is 61 degrees. Alright, unfortunately, in trig, we don't always have two angles given to us. As in the triangle below here, we notice that they're asking us for an angle. They're asking us for angle theta, but we don't have the other two angles. We only have one. We know that we have a 90, but we don't even know the other one. So they had to come up with a way to solve problems like this, and we are going to use SOHCAHTOA again. So our primary trigonometric ratios of sine, cos, and tan, to solve problems like this, where we only have one angle given to us, and we need to find one of the other angles. The next slide is a nice little reference page. You can always come back to this page if you're ever confused on what you need to do. It's very similar to when we use SOHCAHTOA to find missing sides, but there's a little twist at the end. So the very first thing is the same as before, and it's always label your triangle. So in this triangle here, we've labeled our sides. We've got our opposite, our adjacent, and our hypotenuse. Again, your hypotenuse is always across from the 90. Your opposite is always directly across from the angle that you're looking for. And the adjacent is always the third side. We then circle the sides that were given. So we circle opposite and we circle hypotenuse just to remind us which side lengths we've been given. We then choose the appropriate trig ratio. Remember, we use our little phrase, SOHCAHTOA. And SOHCAHTOA helps us choose which ratio we're going to pick. Remember, I treat SOHCAHTOA as a checklist, and I always give my free spaces, my S, my C, and my T. I always give them a free check right off the bat, and then I check off the letters that correspond to the sides that I circled. So I circled opposite, so I check my O's, and I circled hypotenuse, so I check my H's. Once you're done doing all your checks, one of them should have 3 checks, and in this case it's our SO. So that tells us we need to use our sine ratio. In step 4, you see they've set up your sine ratio. Sine of theta is equal to 17 divided by 29. That's your opposite divided by hypotenuse. And in step 5, we actually have to solve this thing. So, before, we used to use regular sine to figure out missing sides, but that only works when you're given an angle. When you're looking for an angle, on your calculator you have to push the second button first. Your second button is a different color. It's in the very top left-hand corner of your calculator. You need to push that button Then you need to push sine, so second sine, and it should look like this. Sine, and then it does a little -1 bracket, and that should show up on your calculator. You then put in the numbers, so 17 divided by 29. That's our ratio that we had found earlier. And when we put that in our calculator, it'll give us our answer. And our answer in this case is 36 degrees. If you put that in your calculator, you actually notice you got 35.888 degrees. For trigonometry, when we're dealing with angles, we always round to the nearest whole angle, so we don't do decimals with our angles. All right, this is a good slide to go back to if you're ever lost and confused on what you need to do. But we're going to do some practice so that you're getting good at it. Here's two triangles. Your first step is always label it. So this is my opposite, my hypotenuse, my adjacent. My second step is to circle the sides that I'm given. So I'm given my adjacent and I'm given my opposite. Step 3 is I have to figure out which trigonomic ratio to use. To figure that out, I use my checklist of SOHCAHTOA. I always check off my first letter in each. And then I check off my opposites, because I circled my opposite. And I check off my adjacents. Once I do that, one of them should have 3 checks. That tells you which ratio you need to use. In this case, we need to use tangent ratio. So right there, I've written tan of theta. That's what that is. So tan of theta equals opposite, which was 13, divided by, opposite divided by adjacent. The adjacent is 12. Now to actually punch this thing in your calculator, you need to go second tan. So second, and then tan. And in your calculator, it'll pop up like this, tan -1 bracket. Your ratio that you have right here, that's the thing that goes down there. So it's 13 divided by 12. If you put that in your calculator, second tan, 13 divided by 12, and hit enter, you would get an angle of 47 degrees. All right, let's try another one. First step, label the triangle. So, opposite, adjacent, hypotenuse. Next step, circle the ones you're given. So I'm given my opposite and I'm given my hypotenuse. Third step, choose a ratio. The ratio you choose is based off of SOHCAHTOA. You're going to check off your S, your C, and your T for free. And then you're going to check off the ones you have circled. So your H's and your O's. Whichever one has all 3 checks is the one you use. So in this case, we're going to use sine of theta equals opposite 6.5 over hypotenuse 8.2. You're then going to second sine this thing. Whenever you're looking for an angle, you have to hit second sine. You're going to get sine -1 like that, and the ratio goes inside the brackets now. Whatever you get, that is the angle you're looking for. So we are looking for 52 degrees. Fantastic. At this point, if I were you, I would try to pause this video, maybe try one of these on your own, just the first one, and then watch the video and see if you got the same answer. If you did, then pause the video again and try the next two, and then check your answer again with the video. Your first step, you're going to label the triangles: opposite, adjacent, hypotenuse. Second step, you're going to circle the ones that you have. So I have this side length and I have this side length. So I know I'm going to use my O and my A. Third step, figure out which trigonomic ratio you want to use. To do that, you write out SOHCAHTOA, and you give the first ones all free checks, and then you check off your O's and your A's. This one has 3 checks. That means you need to use tan, and our tan ratio is opposite over adjacent, so 6 divided by 3. Remember, anytime you're looking for an angle, you have to do second and then your ratio. So we're doing second tan. So tan, and then this little -1. That little -1 tells us that we're doing second tan. And the fraction goes inside the brackets. If we put that in our calculator, we get 63 degrees. Hopefully you tried that on your own, and you're looking back now and you got that right. If not, then maybe watch this next one, see if you can catch on to what you missed, and then try the third one on your own. First step, every question when you have a triangle already built for you is you need to label your triangles. Opposite, adjacent, hypotenuse. Second step is circle the sides that you know. So I know my adjacent is 8 and I know my hypotenuse is 10, so I circle both those letters. My third step, I'm going to use SOHCAHTOA to decide which one of these I want to use. I get a free check on my first ones. I check off my H's and I check off my A's. Whichever one has 3 checks is the one we're using. So I need to use cos theta equals adjacent over hypotenuse. Any time that we want to find an angle, we have to do second cos. So cos -1. And then the fraction goes inside the brackets where the angle used to be. We put that lovely thing into our calculators, and we get 36.8, so that would round up to 37 degrees. All right, last one. If you haven't tried one on your own yet, I highly recommend you try one now, just to see if you know how you're catching on to this thing or not. Maybe you can see where you're making mistakes. My first step hasn't changed. I have a triangle. I need to label that thing. This is my opposite. This is my adjacent. This is my hypotenuse. My second step, I want to circle the sides that I know. Just as a reminder that those are the things I'm using. My third step is writing SOHCAHTOA. And the reason we're writing up SOHCAHTOA is we need to use it to decide which one of these ratios I want to use. You then check off your S, your C, and your T for free. You then check off whichever letters you've circled. So I have circled O, H. So I circle off all my O's and H's. And I discover that sine, so SOH, has 3 checks, so that's the one I need to use. Sine of theta is equal to your opposite, which is 11, divided by your hypotenuse, which is 23. Anytime I'm looking for an angle, I have to hit second sine. So it's sine -1, and then the 11 divided by 23 will pop up where my angle used to be. My calculator, I'm hitting second sign, 11 divided by 23, and I get 28.5. That would round up to be 29 degrees. That does it for this flipped class. So that's a pretty short, quick one. Remember to make sure you've written your notes in your notebook and bring it to class and be ready to practice your newfound skill of finding angles.